In our next section, we're going to combine a couple of concepts that we've already looked at. One is working with exponents and the rules of exponents, and the second is how we deal with radicals, and in particular, radicals other than a square root. And so when we look at these two things together, we find that we can have rational exponents, exponents that are fractions. And so as a reminder, the power that a number is being raised to, or an expression is being raised to, that's going to be the numerator of the exponent. That's the number of factors multiplied together. The index is going to be the denominator of the exponent. So that's the number of identical factors that are required. And so let's take a look at a couple of examples. X raised to the 1/2 power. That's another way of saying the square root of a number. X to the first, and then the index is 2. All right? If we were to go ahead and take a look at a situation where we're taking the fourth root of x to the third, the index would be our denominator, so that's a fourth, and then x to the third power, the power would go in the numerator. So x to the 3/4 power would be the same as x to the third, and taking the fourth root of that. So let's go ahead and do a couple of examples. So convert the radical expression into a base with a rational exponent. So remember, our index is going to be our denominator. So the denominator of the fraction is 7 because this is a 7th root, and then it's x squared, so x to the 2/7. Similarly, y to the third, and we're taking a 6th root. Is it okay to simplify that fraction? It turns out that this will be equivalent. That's the same as taking the square root of y. R to the 4th to the 6th. So the index 6 is our denominator. The exponent 4 is our numerator. So the same as r squared and taking the cube root of that. You go ahead and try the remainder, 4 through 8. You can pause the video, come back and check your work. So taking a look at the remainder of these, in number 4, x to the 6th, and this is a cube root, so x to the 6/3, y to the 4/3, so we're going to simplify that down to x squared, y to the 4/3. In the remainder, we have numerical bases, and this works the same. 2 to the 2/3 power, so 2 squared, and then taking the cube root of that, 2 to the 2/3. 6 to the 5th and taking a 10th root, 6 to the 5/10, which is going to be equivalent to 6 to the 1/2, taking the square root. 7 simplifies down to 3 to the 3rd, and number 8, 8 to the 4/3. Can we go the other way? Absolutely. So if I take a look at something like x to the 2/9, okay, so that tells me the power is the numerator, x squared, and then the denominator is the index. So this is the 9th root of x squared. Y to the 4/12. 12 is my index. 4 is my power. What can I do here? I have x to the 1/3, y to the 4/3, so I know this is a cube root, and I have two different variables. X to the first power, so I'll just write x, and then y to the 4th. Same story as last time. Go ahead and pause the video, work through the remainder, 12 through 16, come back and check your work. Okay, now let's take a look at what you've got. So in number 12, we split that because you have different indices. So x squared to the 3rd, and then the y is to the 3/4, so y to the 3rd, and taking the 4th root of that. In number 13, 4 to the 3rd, and we'll take the square root of that expression. In 14, we have a cube root of 8 to the 5th. 15, again, two different indices. 9 squared, and then taking the 4th root of that. And 27 to the 5th, taking the cube root of that. And in 16, the 4th root of 5 times the square root of 6. So just a reminder that when we have exponents, we have rules for how we operate with those. Multiplying powers at the same base, dividing powers at the same base, raising a power to a power, zero and negative exponents. And these same exponent rules apply to rational exponents. Raising a power to a power, we would actually multiply the two exponents. So as an example, x to the 2/3 raised to the 5/2. So 2 times 5 is 10, 3 times 2 is 6, 10 over 6 reduces to 5 over 3. Powers with the same base, I can add the exponents. X to the 1/3 times x to the 4/3. 1 and 4 is 5/3, so x to the 5/3. Negative exponents is an invert, but multiplying powers with the same base, adding the exponents, 7 and negative 5, so that's 2/3 x to the 2/3. So let's take a look at a couple of those. Practice operating with exponent rules. So 2 to the 1/2 to the 2/3 power. Power to a power means I multiply the exponents. So that's 2 to the 1 times 2 over 2 times 3. 2 over 6, that's 2 to the 1/3 power. Multiplying again, 1 times 9, 3 times 4, that's 4 to the 3/4 power. Powers with the same base, I'm going to add. So 5/3 plus 1/3, that's x to the 6/3, that's x squared. Again, go ahead and pause the video, and you can work on the remainder of the examples yourself, come back and check your work. Okay, so let's see what you've got. In number 20, powers with the same base, we're going to add the exponents. 2/5 and 1/5 gives us 3/5. In 21, raising a power to a power, so I'm multiplying these exponents. 6/7 times 1/2, and I can see that the 6 and the 2 are going to have a common factor, so 5 to the 6/14 or 5 to the 3/7. Number 22, 2/3 plus a negative 1/3, that's x to 1/3. In 23, now we need a common denominator before we can add these. Y to the 2/3, y to the negative 4/6. Well, 2/3 in denominator 6 is 4 over 6. 4/6 minus 4/6 is 0, so this is y to the 0. Number 23 simplifies down to 1. And in number 24, I have a product to a power, so that exponent 3/5, that applies to both the x and the y. So x to the 4/3 times 3/5, y to the 5/7 times 3/5, and that breaks down this way, x to the 4/5, y to the 3/7. So take a moment and go ahead and fill out your summary of your notes. 3 things that you learned today, 2 things that you want to know more about, and a big question that you still have, and then anything you want to use in this space as far as sketches, connections, graphic organizers, connections to work that you've done in other classes, random thoughts, those things can all go here.